This conference will now be recorded.
This conference will now be recorded. Right. So in today's session, let us understand about the importance of equals and hash code methods. The importance of hash code methods, importance of equals and hash code methods, and yeah, what is the contract between these two methods? So this is more important. This plays major role, so we should be very clear about these two methods. All right, so first question, where do we see these two methods? So where do we find these methods? These methods by default. It's the first question. So for every Java class, there is a parent class. What is that? That is what object class. Object is a predefined class. So this is the super class or parent class for every Java class. To write any Java class, so this is what hash map example 3, right? My class name is what? Hash map example 3. Of course, this is a child class for what? One super class. What is that? What is that class? Object class. So object class is the parent for each and every Java class. So object class is the super class, and this is what child class. In a similar way, I have a predefined class called string class. I have a predefined class called string buffer, string builder, integer, right? I have n number of classes. These are predefined classes. Hash map example 3 is the class that I have written, but string is a predefined class. All right. So this is also extends what? Object class. So this is the default of behavior in Java. So we don't have to explicitly do extends object, string extends object, or hash map example the extends object. We do not have to do that. So that happens internally. So hash map example 3 extends what? Extends object. We don't have to do it. We don't have to do this. String extends object. So these are by default internally. It takes care of it. JVM takes care of it. So each and every Java class by default extending what? Object class. So object is the parent class or super class. Let us understand that what are the methods available in the object class. I'm getting into the source code of object class. Just have a look. So this is what object class. Can you see when it is introduced? JDK 1.0. JDK 1.0. Since JDK 1.0, this class is available, right? So this is what object class. You can see this one class object is the root of the class hierarchy. So basically, this is the base class, the root class for every class hierarchy. Every class has a object as a super class. All objects including arrays implements the methods of this class, including arrays. So everything is extending this object class. All right, is that point clear? That's important. Now if you look at, so it has some register natives. This is a native method. So this is calling as part of static, meaning that as soon as the object.class file is loading into the class loader subsystem by as part of JVM architecture, so you should remember that class loader subsystem, every class loads the class before it's executing it and validates it. As part of that, static blocks will get executed, and this is calling that register natives static method. Anyhow, let's move on. So this is also a native method, get class. Okay, the object that represents the runtime class of the object. What is the class name? What is the class? If you give some object and if you get on top of it get the class method, right? It gives the class name. Okay. Yes. So coming into this, what is this method? HashCode method. HashCode method is declared as part of the object class. This is what the point you should remember. Hashcode method is declared in object class. So it is a declaration, right? So do you see any implementation over here? No, we don't have implementation. And if you see, there is one special keyword here, native. Native means that this method is not implemented in Java. So this is implemented in some other language. Okay, this is a native method. The implementation is not here. Okay, maybe that could be in other programming language, say for example you can just say C language. Okay, so that C language, the code might interact with the hardware system, or it generates some unique number to this hash code on the given object. Okay, on the given object, if you call the hash code, it is going to return a hash code value for that object. Okay, so you can see the return value. The return value is what? A hash code value for the object. Whatever the object you are calling on this method, that object hash code value is going to return. And what is that hash code value? That you cannot guess that. Okay, that's all depends on the underlying logic of this implementation of by native uh, programming language. Okay. Okay, so here you can see that the hash code method defined by a class does return distinct integer for a distinct object. So for different objects, it is going to return different values. That's what unique hash code value written by this method implementation. Okay, so this integer value, how it is returning? This is typically implemented by converting the internal address of the object into integer. So internal, it is what the implementation is. So it takes the address location where that is getting stored in the memory, and it takes that and that will be converted into integer. Okay, so this implementation is is not required by Java programming language. By default, the underlying the programming language will take care of it wherever it is implemented. Okay, so as part of JVM architecture, so there's something called linking to the native libraries, native APIs, if you remember. So that's what whatever the native libraries it has, JVM is going to load all the libraries and keep it available. Whenever we are calling this, it gets that implementation and executes it for us. Okay, and what this method returns? This method returns a unique integer value. Okay, all right. So and we have something called equals method. We have something called equals method here. Okay, what equals method is doing? Simple. It's very simple. It is returning. It has implementation. Okay, it has implementation. Equals method has implementation. What is that implementation? Only one line of code. What is that? It is doing this. This is equal obj. So this means what? The current object. The current object in the sense on what object the equals method is called, that particular object. So I have a test t is equal to new test and a t dot equals I'm calling. So there this refers what? T, the current object. Whatever the object you created and calling this method, right? That particular object. Okay, so this equal to object, and this is another object, whatever the object that you are passing as a parameter. So if both are equal, through double equals to operation, double equals, what it is going to check is, this is going to check the references address, basically addresses. You can just imagine that the addresses of these two objects, if the addresses of these two objects are same, then it is going to return true, otherwise it is going to return false. See here, there is a lot of story here in comments. okay, indicates whether some other object is equal to this one or not. So it is going to compare two objects. Okay, so both are same or not. That's what it is going to check. Okay. Okay, so here you can see. Okay, so it is a chance to. This is fine. So yeah, so note that it is generally necessary to override. Note that it is generally necessary to override the hash code method whenever this method is overridden. Can you see that? If you are overriding equals method, so it is required to override hash code method also. Overriding means like, so this is the super class for all the classes, right? So these methods are available by default in each and every Java class. These methods are available by default into each and every class. So in your class, if you are overriding equals method, then it is compulsory to override. It is required to override a hash code method also. Okay. So the reason. So I'll give you an example of hash map. Okay. Uh, so let's see here. So as to maintain the contract, general contract for the hashcode method, which states that equal objects must have equal score, equal hash codes. So this is the contract. This is the point you should remember. Okay. So if we say two objects are equal through equals method, okay, you have ABC and ABC, two string objects. If these two strings are equal through equals method, then they must return the same hash code. They must have the same hash code. That is the contract. So if you leave that job to the native programming language, okay, native programming language, so that where that is going to return the address locations, okay, so that may not return the same hash code value, even though the object data is the same. So that is the reason you will have to implement both of these. If you are implementing equals method to check, then the hash code also should be same. Okay, so let me make a note of it, okay, for you. So there is a contract. There is a contract between equals method and hash code method equals and hash code methods. There is a contract between equals method and hash code method. What is that contract? Okay, point number one. If two objects are equals, then the object must be the object hash code. The object's hash code value must be same. Hash code value must be same. Of course, right? In general, like if you leave that, okay, if you leave that, uh, if you don't override the equals method, by default it compares, okay, it has a comparison of double equals to operation, right? So assume that you have a string object here, string s is equal to new string of, okay, s is equal to new string of hello. This is what one string object. Okay, so string s1 is equal to new string of hello, string s2 is equal new string of hello. Okay, so now if I compare these two, can you tell me what is the output that I can expect? Okay, or just I'm printing this. Okay, tell me what is the expectation? What is the output here? Println of s1 equals to s2. What is the output? Can you tell me, Aditya? what is the output? So am I going to get a true or false? Because it's a double equals operator, right? It's comparing. So it returns false. Yes. Why it is going to return false? Why it returns false? We know that. Yeah, it returns false. Excellent. Why it returns false? Because different objects. Okay, because different objects. As both are different objects, so different objects are going to store in different memory locations, of course, right? So as both the objects are different, so they store in different memory locations. Say, assume that this is the memory location where the objects get stored in the heap memory. Okay, just make a note of it. Okay, all the objects get stored in the heap memory. Heap memory. Okay, in the heap memory, as soon as I create a new string of hello, so it is going to create one object over here, and the content is what? Hello. Okay, so this is what, and hello, and again I'm creating, excuse me, this guy is referred by what? This guy is referred by like some particular address location. So there is something called stack memory. There is something called stack memory where the local variables and get stores. Okay, so here is variable. What is that variable? S1. S1 is my variable, and this S1 will be pointing to what? This guy will be pointing to this particular object hello, this particular object hello, and see, like if it has some address, just I'm giving some random number as the address location, but should not be the case in real life, right? So that could be a different memory address, but just for example, I have given address location is what? Okay, so this number. So meaning that, so this guy is going to have this particular address. This is the local variable. So here, so S1 stores captures that particular address location. This is how internally it handles. Okay, so in the stack memory, the reference variable gets stored and the object gets stored in the heap memory, and the stack memory variable is going to capture or hold the memory address of this hello. Now I have created a new string of hello, one more object. So that gets stored in different memory location. That will get stored in different memory location because you created a new. When you create an object using new keyword, definitely it is going to take a different memory location. No doubt in that. Okay, so this is going to take a different memory location. So here this creates hello, and in the stack memory it creates another object. Okay, sorry, in the stack memory it creates another variable. What is that? S2, and it is going to hold the address location of what? Okay, so that particular S2, right? So meaning is pointing to this. Okay, different. Now it's very clear. Compare two. One is objects. Clear, right? Now if I compare S1 to S2, S1, these are okay. These are the variables it is going to check. It doesn't include S1 is this variable and this S2 this one. Are both are same? This one and this one, are the both same? No, right? Both are not same. Both are not same. They are different. So it is going to return false. So this will return what? This will return false. So hope this is pretty much clear. Run this. Why is that? You have to know. Okay, false is the output. Now the same thing I'm going to write. Okay, I'm going to write Okay, so yeah, let me not get into that details. Okay, here the point is, okay, here the point is, when I say this one and this one, both are same or not? I mean, in general, if you look at the if you're comparing two objects, meaning that what you are trying to compare, the you will compare the objects, not the reference. Our main motto is string s1 and s2 both are same or not. That means that the content is same or not. That's what our motto. Okay, when I'm trying to compare two objects, meaning that are are the objects the same or different in content wise, not the reference wise. So content wise, both objects are same or not. That's what we'll have to check actually. But what is happening here? It is comparing the references, but not, okay. It's comparing the references, but not the actual content, actual data. Okay. Of course, if you get the hash code value of s1 and s2, okay, if you get the hash code value of s1 and s2, you will be getting a different hash code values, of course, right? Because that is a different memory location, this is a different memory location. So s1 dot hash code, that gives a different memory location. S2 dot hash code gives a different memory location, because both are stored in different places, got it? And can I call the hash code method an s1 or not? Of course I can call that, because string is extended by what? Object class, and object class is having what? Hash code method. Okay, so this is what the hash code methods. If you look at, both returns at different hash code values. Awesome. Okay, so this is written, looks like the same hash code value, but there is no guarantee that. Okay, why? Yeah. Wait a minute. Why this is happening? So this is what a string. Okay, string, and inside the string class, the hash code method is overridden to return the same hash code value if the content is the same. So here, so value is what? Content, string value, and it is iterating the string value character by character, and implementing this some logic over here. Okay, hash, the h is called hash. Okay, so um, some taking some prime number, unique prime number, you can take any prime number, multiplied by the existing hash plus value of I, value of I, value of I in the sense the character. So that's how they are generating some unique hash code value and returning it. Of course, this returns obviously same. Okay, this returns obviously same because it is overridden. Now let me show you another example. String buffer example. I have a string buffer, sp1 is equal new string buffer. Okay, hello, string buffer sp2 is equal new string buffer of hello. Okay, now let me print hash code values of sp1 dot hash code value and sp2 dot hash code value. Okay, let me run this. Okay, can you see the hash code values for this? So here it is given a different hash code value, and this is a different hash code value. The reason, because in the string buffer class, okay, in the string buffer class, there is no hash code method. There is no hash code method. Can you see? Do you see any hash code method here? No. But if you go to string class, so you have hash code method. You have hash code method, because they have overridden. They have the hash code method is overridden for returning unique hash code value if the content is same. That is the reason you will get what? Always, okay, the same hash code value for strings. So that is the reason here you see the same hash code value for the both the strings. Okay, if this is not overridden, okay, if this is not overridden, then it goes by default reference comparison. Okay, it goes by different by default reference comparison. Okay, so here if I print sp1 is equal to sp2, I'm going to get what? False. Of course, both are different addresses. I'm going to get false. So here also I'm getting false. Here also I'm getting false. But here it is overridden for returning unique hash code value. Here it is written to return unique hash code value. Okay, but here, if you look at here, um, uh, we are printing hash code value. This is giving the same hash code value, and this is also giving the same hash code value. Okay, remember that. Okay, remember that when you are comparing this one, this reference is going to compare this is a reference comparison. Absolutely, by reference comparison, it is not the hash code comparison. Okay, this is not the hash code. So address location is different, hash code is different. Okay, address location is different, hash code is different. So at this line it is comparing the address locations, not the hash code of these strings. Okay, and here also it is going to check the address locations, not the hash code. Right, so if, but in this case it is returning different hash code values, but here it is returning same hash code value. So these are below are returns the same hash code value because, okay, because hash code method is overridden to return the same hash code value, to return the same hash code value if the content is same. If the content is same, that's what the point you have to understand. And here in the string buffer, so this is going to returns different hash code values as this executes the hash code method of object class, which depends on the native implementation. Not our implementation. Okay, not our implementation. And as both are different objects, returns. Okay, so the hash code methods returns different values. So we're following. Okay, this is pretty much important. Okay, so here we have hash code method printed, returning different hash code values. Why? Because if you click on this, it goes to the object class. So meaning that at runtime it is going to call this object class hash code method, but here it doesn't have any implementation. So it depends on the native implementation, which returns the different hash code values if the objects are different, right? But if you look at the content is same or not, here hello and here also hello. So that is what an issue when you are working with the hash map. When you are working with the hash map, okay, so this is going to be an issue. This is going to be an issue because if you observe here, I am going to create a map object, new hash map, okay, new hash map. So map dot put of key. So I wanted to add my key s1 and its value. I wanted to add the value as, okay, some number. This one value is what, 100. In the similar way, I wanted to add one more object, s2 is equal to 200. Okay, s1 is s1 comma s100 and S2 is 200. Okay, I have two different objects and I have added these and printing this one. Okay, let me also add SP1. SP2. Great, I have added all four objects to my map as the keys. So I have added string and string buffer as my keys. Values I have given some numbers. Okay, so can you see the output? It's very important. Please observe the output. Please observe the output. So hello 200, hello 300, hello 400. Where is my hello 100 now? Where is this guy? Where is this guy? You understand? Do you see the difference? So for string keys, so initially I have added a string S1 with 100, S1 with 100. Okay, S1 with 100. Okay, so S1 with 100, and then again I'm adding S2 with the 200. So that guy is overridden. That guy is what? Overridden with the value. Replace the old value. Old value is 100 and this value is 200 because both S1 and S2 it is considering both are same, because both the objects are having the same content. That is what hello. So uh, the hello of S1 is going to compare with the hello of S2 using equals method. Okay, using equals method. Through equals method, both of them are same. Both of them are same, and it also finds the hash code value of it, S1 and S2. Obviously, the hash code method also overridden in a string class to return the same hash code value if the content is same. So obviously S1 and S2 hash code values are also what? Same. So by means of equals and hash code methods, it is same. S1 and S2 both are same. As S1 and S2 are same, keys are same, the value is going to be replaced. That we learned already. In case of hash map, if the key is the same, the value will be what? Replaced with the new value, right? And hello 300 and hello 400, they are kept as it is. Both it maintains both the objects, because even though if you look at the string is what? Still hello. The string is still hello, but it added it as a new entry. Why? Because this is going to return a different hash code value, this is going to return a different hash code value, because both the hash code values are depends on what? The memory address locations, and this hello placed in different memory location, this hello placed in different memory location, so it returns different hash code values compared to this one. So altogether all three are different hash code values, so it is going to uh, place in different as different entries. But the first case is S1 and S2, both are string class methods. So both are string class objects. Inside the string class, equals and hash code methods are overridden. Okay, so hash code method is overridden to return the same hash code value based on the content. If the content is same, it is going to return the same hash code value. And equals method is overridden to for the content comparison instead of the reference comparison. Okay, so let me tell you one more thing here. Okay, right. So here, let me check one more thing here. Okay, so system out println sp1 dot equals of sp2. So I'm checking equals method also. Okay, sp1 dot equals of sp2, and here also I'm going to check s1 dot equals of s2, s1 dot equals of s2, s1 dot equals of s2, right? So what is the output here? What is the output here? We are sure that this is going to return what? True. And what is the output here? Of course, this is going to return false. Right or not? Why? Because so in the string class equals method is overridden. If you get into the string class, equals method is there, and it has a logic to iterate through the string content using a loop, right? So here you can see that it's getting all the things and looping through that and comparing each character by character with the first string of the first character, second string of the first character, second string of the first string of the second character, okay, second character second string. So character by character it's comparing, and everything is same, then into they're returning false. So not the reference based, not the reference based. So obviously we get a true here because it's content based, and both S1 and S2 has same content. But here, if you look at SB1, here if you see, it is not implemented in string buffer. By default, it goes to the object class. If you look at the object class, what is the comparison here? Reference comparison, address comparison. Obviously, both are new objects, so they store in different locations. Okay, meaning that having different references, it is going to return false. It is going to return false. Obviously, in this case, it is going to return false. Hope you understand now. Okay, so here it is going to return true, then false. Okay, so are you good with the equals method and hash code methods of the object class and string class? In the object class, equals method is implemented to compare the references of the objects. And in the object class, hash code method is not implemented. It is a native method. So it depends on the native libraries, and it gives different hash code values even though the content is same. It doesn't know about that. If it is a new object, it returns a different hash code value. Got it? Okay, so here, perfect. So here, why do we this why do we need to discuss all this? We are actually discussing about the hash map, but why we need all these things? Because so when you are adding entries to the map, okay, always map is going to check two things. Map verifies the keys when we add a new entry. When we add a new entry, so what is that verification? What is that verification? Okay, first check. Okay, it checks the hash code value. Okay, hash code value comparison, and compare with the existing keys. So what, when you add an entry, okay, when you add a new entry to the hash map, okay, so map is going to verify the key. How it is going to verify? It gets the hash code value of the key whatever you added and compares with the existing keys. Okay, excuse me. It compares the hash code value with the existing keys. For suppose if there are any keys, okay, any keys, okay, any keys match any keys found the same hash code value as like as the new key, as like as the hash code value of the new key, hash code value of the new key. If there are any keys found the same hash code value as like as the hash code value of the new key, okay, existing keys. Then what it does, it cannot say that both are equal. The hash code is same doesn't mean that the content is same. There is no guarantee. The hash code value is same. There is no guarantee that okay, the values are going to be same. Okay, the values are going to be same. Right. So here, if you see, if the hash code value is the same, okay, then map implementation, what it does, map does the content comparison using equals method. If still both are same, with respect to the equals method comparison also, then map consider that as a same key, or duplicate key. Okay, duplicate key. So if it found duplicate key, then what it does, if it is a duplicate key, what it does, it overrides or it replaces its value with the new value. Make sense? Makes sense how it works? Hoping that you are clear about this point. All right. So this is just an example of string and string buffer. Of course, can I have my own class and can I keep it as a key? Of course, I can do that. So I can write my class, say for example, product. Okay, so I have a product class where I have ID. Okay, where I'll be having ID. Okay, so I might have product name. Okay, product name, and come on, and product condition. Okay, so is damaged or so. Damaged product or not, something like that. So here I have setters and getters. This is just a pojo class. Okay, this is just a pojo class where I see setters and getters. Where I see setters and getters. Okay, this is what my product class. Okay, why there it's already defined. Oh, okay, product model, I'll say. Okay, class product one. Okay, as a model class or bean class or pojo class, all are same. Okay, so at high level, what I'm doing here is I'm going to create my map. Okay, this is of going to take key value pairs of key as a string and value as my product, or else let me make my product as a key, and a value is just I'm going to store uh, quantity. Okay, so how many are there with the product, this particular product. Okay, this is what my product map. Okay, so product map. In the product map, what I do is I'm planning to add the products. Okay, I'm planning to add the products. Here let me take the price also, private double price. Okay, like here. So now let me generate a setter getter for this as well. Anyhow, for now I might not use the setters getters, but just it's a general practice while defining the pojo class. Now I wanted to have the constructor also. I wanted to generate the constructor using the field, these particular fields. Okay, right. So my class is ready with the setter getter and with the constructor. Now I'm going to create multiple product objects. I'm going to create multiple product objects and I'll add them to my map. Okay, so product map dot add of put of. Okay, I should add the key value pairs for my map. I want to add a product object as a key. I wanted to add product object as a key. Okay, and this guy constructor is, I have multiple constructor product model. I'm sorry, product is different. Somewhere else we have its product model. Okay, product model. So one, but uh, and the product name we maybe the not sure not. Okay, so I'm going to so I'm not damage item and so I'm just going to give this out. How many objects? How many that after and how many tabs are under? How many I have 100 objects. Similar way, add few more objects. Okay. So here the ID is 2. I'm going to have okay. I'm going to have mobile. Okay. After and this is going to be like 20,000. And this one, I have 200 mobile. I have another which is 3 and I have another product mode. So here the laptop is yes laptop, but it's a damaged item. It's yes laptop, but here it's damaged. Okay, true. So the damaged items is a damaged item. So the cost is just 15,000, and I have 100 damaged items. Okay, and here if you look at okay, and okay, here if you look, I have one object, one walls 30,000. Again, I got for 100 laptops manufactured. Okay, so this is what my map. If I print my map details onto map, how okay, how I'm going to get that here. See, okay, okay, so product run this after the references value. So to understand that product is this product model at the rate some address location in hexadecimal format product model. I can't understand like how is the actual product, right? So what I can do is I can implement here so that I will use the toString method here. You get to know what is the product, what is the product names. Will override the toString method. Okay, toString here over. Okay, this is what toString method. What I do is I'll just call this dot get. Okay, get name. I'll just return the name. Now see it runs through. When you see laptop 100, laptop 300, laptop 100, laptop 100, mobile 200. I'm using laptop now. Earlier it was memory address, right? Because now I have giving some memory over in the toString method already in just name. This is now accessing that object is going to calling the super class object class toString and printing that. So in the object class super method object toString method. So this is the implementation of this is class name and that. So over in the okay in the string method now it is printing active. So if you observe how many how many entries are there, how many entries are here, 100, laptop 300, laptop 100 and mobile 200. So total 4 entries. So how many entries I have added? If you if you observe closely, by for some reason I have the same object here. This is the object is exactly same as this or not. As you say, two one. I want to do that, but here take it classes is here doing here is where I'll just keep p1 p4. Okay, so p4 both are same hash code value this one hash code value in having exactly the same content. Okay, it has to return the same hash code, it has to return the same hash code, right? So that is why like I did not return any I did not implement any hash code method over here. So let us implement that. Okay, anyhow we don't have to worry about that. We can generate that in Eclipse. We have a provision of that generate hash code and equals method. Can you guys see here? It has given both hash code and equals, meaning that if you are planning to override a hash code method, it is compulsory to override equals method also. Both have a contradiction. Now, on what objects you wanted to check if both the objects are same or not. Okay, so the ID also matter for us. So let me take everything, or if you have any specific a few things, then you can go by that. Okay, so this is the implementation of hash code, taking some prime number and multiplying the prime number with the result. Initially it is 1 plus property. Based on that, if it is true, giving some unique primary number, or not if it is returning some prime number for boolean. If it is a string, then so string dot hash code method can be called. This is going to call the string class hash code method, this one, and return some unique thing. Okay, all right. So then so result will be prime plus how many properties we have, those many times it's doing that. Okay, then it's converting into some unique value. This is just to suppress the number which is otherwise it may, because you are multiplying the bigger number, and if you have more properties then it goes beyond out of limits of your integer, and it throws like out of memory error. So to suppress that, so we're handling some bitwise, we're using some bitwise operators here to minimize that. Okay, so this is what we're going to return the unique hash code value. Okay, as it is considering the data is damage property, name property, id property, price property. So as it is considering all these properties, so okay, so it returns unique hash code value. For the same content, it is going to return the unique hash code value. Okay, so equals method, if you look at the equals method, so it is going to compare the content. So product model is damaged of the first item is same as the other item or not. The same way name of the first item is equal to the second item or not. The similar way ID of the first one is same as the second ID or not. The same way price of first one is same as the second item or not. Price means this dot price. Other dot price means second object. So if everything is same, then only it returns true. Otherwise, it doesn't return true. So basically, the point is if two objects are same through equal hash code method, their hash code must the content must be equal. If the two objects are equal through equals method, their hash code must be same. That is what the contract we are achieving here. Now just run this same code again. I just modified the product model class, not the map stuff. Okay. Now can you see how many laptop objects I have? Only two entries. But earlier we do see three entries or not. We do see three entries, but now only two entries of laptop. Here, if you look at the laptop objects, this is what laptop. Uh, what is the 100, and the second time the fourth one laptop 300. This one and this one both are same, right? So if you look at the latest value, you can see it's laptop 300, and the other case is laptop 100. This one, because this is having a different ID and different thing, so it's going to be different. Okay, so as there is a confusion what laptop it is, so you can customize this logic. You can customize this logic. What logic? Two-string logic. Two-string logic. Get name. Also, let me get the ID. ID equals to, okay, this dot get ID. Product ID. Okay, just to ensure that, to check. Okay, both are different. Run it. Okay, so can you see laptop ID is one here. So ID one, meaning that first object is taken, but the value, if you look at 300, that is what the one which we added later. Still this is giving a little confusion, right, with this equal and this equal. Let me customize this. Instead of equals, ID is this one. Laptop ID is this one. Okay, so mobile ID is 2. Okay, laptop ID is 1. Laptop ID is 3. 1 and 3 products are there. Okay, product 1 and 3. Product 1 and 3. So if you look at the product 1, this laptop is added first with quantity 100, and again further here it is going to be like the key is the same, content wise and hash code wise. So value is what, 300. So this is going to replace with the old value. So now this 100 becomes what, 300. So this ID 1 is going to replace 300. So you can see that ID 1, because ID is same, right? So you can see that this value will be replaced with what? 300. Okay, 300. And these are going to be like as it is, because these are different. This is because ID is different and its damaged property is also different. Okay, so that is how we'll have to take care of equals and hash code methods of our pojo classes when you are planning to add these as a keys of your hash map. This is more important. This is more important, and we do get this kind of requirements, so you must be very clear about all this stuff. All right, is that clear, Aditya? Do you have any questions? So all we discussed about the equals and hash code methods, nothing else. If we summarize, the simple points are: if two objects are equals using content, their hash code must be same. If you see two objects hash code is the same, the content must be same. So there is a contract between them. Okay, all right. And tomorrow I will I'll continue this discussion. So using yesterday's discussion and today's discussion. And if you remember yesterday, the discussion of how the map is going to allocate these items into the buckets based on some index, right? So the item is going to add as finding the index value, nothing but a bucket, and store that as a node. Okay, the node value will be having key and value, also hash code, you remember. Okay, so hash anyhow, we'll continue that tomorrow. So this is where you will get where that you will get that clear. Okay, so first it finds the bucket, and then it also checks the content comparison. Okay, so we'll discuss that tomorrow. Okay, hope this is clear whatever discussed so far. Okay, we'll continue tomorrow. Thank you.